11 April 1941, Wright Field, Dayton, Ohio. The conference room at Wright Field smelled of cigarette smoke and mimeograph fluid when Colonel Carl Green opened the folder marked Hemispheric Defense Weapon System and began reading specifications that seemed pulled from science fiction rather than engineering reality. Wingspan 230 feet, gross weight 265,000 pounds, range 10,000 miles, service ceiling 45,000 feet. The morning sun cut through the Venetian blinds in precise horizontal lines across the mahogany table, where 8 men from the Army Air Corps Materiel Division sat reviewing Consolidated Aircraft Corporation's proposal for a bomber that could strike Nazi-occupied Europe from bases in North America should Britain fall. A contingency that in April 1941 seemed not only possible, but likely given the Wehrmacht's successes in North Africa and the Balkans, and the Luftwaffe's continued pressure on British cities. Green lit another Camel, the match flare brief and sulphurous, and studied the cross-section drawings showing 6 Pratt Whitney R-4360 Wasp major radial engines, each a 28-cylinder beast producing 3,000 horsepower, mounted in a pusher configuration on the trailing edge of a wing so massive it would require a center-section fuel tank holding 21,116 gallons. The engineering challenges were staggering. The aircraft would need a pressurized crew compartment for flights above 40,000 feet, where outside temperatures dropped to -67 degrees Fahrenheit. Retractable landing gear capable of supporting 130 tons, and defensive armament including 16 20mm cannons in remote-controlled turrets guided by analog computers that didn't yet exist in production form. Major James Whitley from Bomber Branch pointed to the estimated first flight date, late 1943, and asked the obvious question about whether the war would still be on by then, whether Britain would hold, whether the Reich would collapse under its own logistical impossibilities before this aluminum Leviathan ever left the ground. Green tapped ash into a government-issue brass tray and replied that the Air Corps was not in the business of gambling on enemy collapse, that strategic planning required capability overmatch, that if the B-17 Flying Fortress represented the current state of the art with its 2,000-mile range and 6,000-pound bomb load, then the future demanded something that could fly twice as far, carrying 3 times the payload to targets the enemy believed unreachable. The meeting continued through lunch, through detailed discussions of wing loading ratios and flutter analysis, and the structural challenges of a fuselage 163 feet long, nearly as long as the wingspan of a B-17. By 1500 hours, the committee had reached consensus. Consolidated would receive a development contract for 2 prototype XB-36 aircraft, with first delivery scheduled for May 1944, a timeline that assumed no significant material shortages, no competing priorities from other programs, no fundamental redesigns during testing. Green signed the authorization paperwork with a fountain pen that left wet blue ink on the cream-colored forms, each signature a commitment of millions of dollars and thousands of engineering hours toward a weapon system designed to win a war that might be over before the first aircraft rolled out of the Fort Worth factory. Outside the window, a Douglas B-18 Bolo made its approach to the Wright Field runway, landing gear down, its twin radials throttling back, a medium bomber already obsolescent, already outclassed by German and British designs, a reminder that in aerial warfare, technological advantage lasted only as long as the next enemy innovation. The folder closed with a soft thump of paper on wood, and Green walked to the operations center, where teletype machines clattered with reports from the Atlantic, where U-boats were sinking merchantmen faster than British and American yards could replace them, where the strategic situation remained fluid and dangerous, where the assumptions underlying every defense plan could change overnight with a single enemy breakthrough or a shift in diplomatic alignment. The B-36 existed now only as blueprints and calculations, as engineers' dreams rendered in mechanical pencil on drafting vellum, as a hedge against the possibility that American bombers would need to fly from Kansas to Berlin without refueling, without overseas bases, without any guarantee of friendly escort or friendly territory for emergency landings. The numbers were clean and absolute in the afternoon light. 10,000 miles meant half the circumference of the Earth at the equator, meant the ability to strike any target in the occupied territories and return home, meant that geography would no longer protect the enemy's industrial heartland from American precision bombardment. Greene returned to his desk and drafted a memo to General Henry Arnold recommending approval of the consolidated proposal, noting that while the B-36 would not influence the current conflict's outcome, it represented necessary insurance against future contingencies and would provide the Army Air Forces with intercontinental strike capability that might prove essential in post-war deterrence scenarios. The memo went into the outgoing classified pouch at 1700 hours, carried by courier to Washington on the overnight train, one more document in the vast paper flow of American military planning, one more commitment toward victory through technological supremacy and industrial capacity. The main assembly building at Consolidated's Fort Worth plant stood empty except for the skeletal framework of the first XB-36 prototype, its massive wings still missing their outer panels, its fuselage a lattice of aluminum formers and stringers that threw complex shadows across the oil-stained concrete floor in the harsh light from the overhead mercury vapor lamps. Chief Engineer Ralph Campbell walked the length of the aircraft with a clipboard, his footsteps echoing in the cavernous space, noting the missing components, the incomplete systems, the gap between planned progress and actual status, now that the war had ended 3 weeks earlier with Japan's surrender following the atomic attacks on Hiroshima and Nagasaki. The prototype was nearly 2 years behind its original May 1944 delivery date, delayed by shifting priorities that had funneled engineering talent and production capacity toward combat-ready aircraft like the B-24 Liberator, which Consolidated produced in massive quantities for the European and Pacific theaters, toward emergency modifications for existing bomber types, toward projects with immediate battlefield application rather than speculative future requirements. Campbell's checklist showed red marks next to major systems. The R-4360 engines were installed but not yet run. The pressurization system lacked its environmental controls. The landing gear remained in testing after failures of the main gear struts under load. The fire suppression system was incomplete. The defensive turrets existed only as mock-ups pending delivery of the General Electric remote control computers. Outside the building, Texas heat shimmered off the concrete ramp where B-24s had rolled out by the hundreds during the war years, where now only a few aircraft sat awaiting delivery to a military that was already canceling orders and mothballing bombers by the acre at desert storage facilities in Arizona and New Mexico. The program's survival was now a political question rather than a military necessity. With Germany defeated and Japan destroyed, the strategic rationale for an intercontinental bomber had evaporated, and the Army Air Forces faced budget cuts that would eliminate thousands of aircraft and hundreds of thousands of personnel as the nation demobilized. Campbell met with Colonel Michael O'Brien from Wright Field, who had flown in to assess the program's status and provide recommendations to Washington on whether to continue development or terminate the contract and reclaim whatever invested funds remained recoverable. They walked the airframe together, O'Brien taking notes, asking technical questions about performance estimates, about whether the aircraft could actually reach 45,000 feet with a full bomb load, about fuel consumption rates for the 6 R-4360 engines, which were known to be temperamental and prone to overheating. Campbell defended the design, arguing that the B-36's range and payload exceeded any existing or projected Soviet bomber by a comfortable margin, that in an uncertain post-war world where yesterday's ally might become tomorrow's adversary, the ability to project strategic air power from the continental United States remained valuable, that the engineering challenges were solvable given adequate funding and schedule relief. O'Brien lit a lucky strike and studied the nose section, where the bombardier would lie prone behind glass panels, studying the primitive radar installation that would guide the aircraft to targets through darkness and weather, studying the defensive gun positions that seemed inadequate for an aircraft that would lumber through hostile airspace at 300 miles per hour. The mathematics were stark. At 45,000 feet, the B-36 would be above most flak, but vulnerable to any jet interceptor the Soviets developed, and intelligence reports suggested Russian engineers were already examining captured German jet technology, including the Messerschmitt Me-262 and Arado AR-234. The meeting concluded with O'Brien promising a full report within 2 weeks, offering no guarantees, acknowledging that senior leadership was divided between those who saw the B-36 as essential insurance and those who viewed it as an expensive anachronism superseded by the atomic bomb, which could be delivered by smaller, faster aircraft requiring less support infrastructure. Campbell returned to the engineering offices where his team continued detailed design work on systems that might never be installed in a production aircraft, where young engineers recently discharged from service worked through calculations for flutter margins and center of gravity envelopes, where the accumulated knowledge of 4 years of development existed in filing cabinets full of test data and stress analysis and wind tunnel results. The first flight remained scheduled for early 1946, dependent on completion of engine testing and resolution of landing gear issues, and installation of flight controls, and 1,000 other tasks that required money and manpower that might not materialize if Washington decided to cut its losses. Campbell drafted a status memo for the Fort Worth plant manager, detailing the incomplete systems and estimating 6 months minimum to first flight, assuming no further delays or budget restrictions, noting that the prototype already represented an expenditure of approximately $40 million with uncertain return on investment now that strategic circumstances had fundamentally changed. The memo concluded with a recommendation to continue the program at reduced priority, completing the XB-36 prototypes to validate the design concept and provide the Air Forces with operational data on very long-range bomber operations at high altitude, data that would inform future aircraft development regardless of whether the B-36 entered production. Outside, the Texas afternoon turned the assembly building into an oven, the metal structure radiating stored heat, the air conditioning system barely functional in the vast interior space where the unfinished bomber sat like a monument to canceled futures and obsolescent requirements, its aluminum skin gleaming dully where panels had been fitted, its empty engine nacelles waiting for the massive radials that would eventually lift it into the post-war sky. The XB-36 sat on the apron at Carswell in the pre-dawn darkness, its enormous wings spanning 230 feet from tip to tip, its 6 R-4360 engines silent, its silver aluminum skin beaded with condensation from the humid Texas air, as ground crews completed pre-flight inspections using flashlights that created moving circles of yellow light across the aircraft's surfaces. Test pilot Barrel Erickson climbed the entry ladder at 04:45 hours, carrying his flight bag and a thermos of coffee, followed by co-pilot Gus Green and flight engineer Ray Carnahan, their boots clanging on the aluminum rungs, their breath visible in the relatively cool air before sunrise. Inside the pressurized crew compartment, the instrument panels glowed with backlighting, analog gauges showing oil pressure and fuel quantity, and hydraulic pressure and cylinder head temperature, a complexity of systems that would need constant monitoring during the 4-hour planned flight profile. Ericsson settled into the left seat, adjusted the rudder pedals, tested the control yoke for full deflection, ran through the checklist with mechanical precision, while outside the ground power unit hummed and the fuel trucks completed topping off the wing tanks with 19,000 gallons of 115-octane aviation gasoline. The program had survived repeated cancellation threats, had outlasted the war it was designed to fight, had consumed $55 million and 5 years of development time to produce this single flying prototype that would demonstrate whether the engineering calculations translated into actual performance. At 05:20 hours, with first light beginning to gray the eastern horizon, Ericsson signaled for engine start, and the ground crew activated the starter motor for engine number 1, the big Pratt Whitney R-4360 Wasp Major, coughing twice before catching with a rattling roar that echoed across the airfield, its 28 cylinders firing in sequence, blue exhaust smoke drifting back from the pusher propeller. Engines 2 through 6 started in sequence, each adding its voice to the thunder, until all 6 were running at idle, their combined 18,000 horsepower creating a vibration that traveled through the airframe and into the crew seats, a visceral reminder of the forces that would drag this 140-ton machine into the sky. Tower cleared them to taxi at 05:47 hours, and Ericsson released the brakes, advancing the throttle slightly, feeling the aircraft begin to move with ponderous momentum, the nose gear steering requiring constant attention as they rolled toward runway 17, the wingtips extending so far that ground crew had to walk alongside to ensure clearance from parked aircraft and buildings. The taxi took 12 minutes to reach the departure end, where Ericsson ran the engines up to full power individually, checking magnetos and propeller pitch and engine instruments, while Carnahan monitored systems and Green worked through the final items on the before takeoff checklist. At 06:03 hours, with the sun now visible above the horizon, Tower gave takeoff clearance, and Ericsson advanced all 6 throttles smoothly forward, the engines accelerating to 2,700 RPM, the propellers biting into the thick morning air, the brakes holding against 18,000 horsepower until he released them and the B-36 began its takeoff roll. The acceleration was glacial compared to fighter aircraft or even medium bombers, the heavily loaded prototype requiring 5,500 feet of runway to reach rotation speed of 110 miles per hour, the nose gear lifting first as Ericsson applied back pressure on the yoke, then the main gear breaking ground at 6,200 feet down the runway, the aircraft climbing out at 300 feet per minute with gear retracting and flaps coming up, and the engines settling into cruise power settings. The flight plan called for a climb to 30,000 feet, followed by performance testing, including stalls and engine-out procedures and control response at various airspeeds and configurations, a systematic evaluation of handling characteristics and systems operation that would generate data for the engineering teams who had designed this aircraft based on wind tunnel testing and mathematical models, but had never seen it actually fly. At 10,000 feet, Ericsson reported smooth handling with slight heaviness in the ailerons, adequate stability in pitch and yaw, no unusual vibrations or control forces. The pressurization system maintained sea-level pressure in the crew compartment as they climbed through 20,000 feet, where outside temperature had dropped to -20 Fahrenheit, where the engines continued running smoothly on their turbo superchargers, where the fuel flow meters showed consumption matching predictions. At 07:21 hours, they leveled at 30,000 feet, 180 miles west of Fort Worth, the Texas plains spreading below in shades of brown and tan, the sky above deep blue and empty of other traffic. Ericsson began a series of gentle banks and turns, feeling the aircraft's response, noting the lag between control input and aerodynamic reaction, the massive wings' resistance to rolling, the solid stability that would make for a steady bombing platform, but challenging fighter evasion. Green feathered engine number 3 at 07:45 hours for single engine out testing, the propeller blades rotating edge-on into the slipstream to minimize drag, the remaining 5 engines maintaining altitude with slight increase in power settings. For 90 minutes, they conducted systematic tests while Carnahan filled out data cards with temperatures and pressures and fuel flows and control forces, creating the empirical record that would validate or invalidate 5 years of engineering assumptions. At 09:35 hours, with fuel state requiring return to base, Erickson began descent back toward Fort Worth, the engines throttled back to idle, the big bomber losing altitude at controlled rate while maintaining indicated airspeed within safe limits. The landing was scheduled for 10:15 hours, completing a flight that would prove the concept's viability, but not answer the fundamental question of whether the Air Forces needed this aircraft in a post-war world increasingly dominated by atomic weapons and jet propulsion and guided missiles. They entered the pattern at Carswell at 0:10:08 hours, configured with gear down and flaps extended, the approach speed 115 miles per hour, the aircraft stable and controllable in landing configuration, despite its enormous size and weight. Erickson crossed the threshold at 10:14 hours, reduced power, flared smoothly, and the main gear touched down with a chirp of rubber on concrete, followed 2 seconds later by the nose gear, the prototype rolling out straight and smooth while he applied brakes and brought the aircraft to taxiing speed. Ground crew directed them to the parking spot where they completed the shutdown checklist, the engines spooling down one by one until only silence remained and the smell of hot oil and exhaust. Erickson signed the aircraft logbook at 10:27 hours, recording 4.2 flight hours, no discrepancies, successful first flight of the XB-36, a technical achievement that had come too late to influence World War II, but would eventually lead to production orders and a decade of strategic deterrence during the early Cold War, when the B-36 Peacemaker represented America's primary means of delivering atomic weapons against Soviet targets from bases safely beyond enemy bomber range, making real the capability that Colonel Green had envisioned in that conference room at Wright Field 5 years and 4 months earlier, when the design existed only as numbers on paper and the future remained unwritten.